So we'll discuss prime factorization. Now, what is prime factorization? Prime factorization is basically writing any number in multiples of the prime numbers. We have seen in the last session prime numbers and composite numbers. So a basic example, we can go through prime factorization as it said here, representing all integers greater than 1 as a product of one or more prime numbers. So a basic example, let's say if I have to prime factor is 12. 12 we know is 2 into 6 and 6 is 2 into 2 into 3, right? So 6 is 2 into 3 and 2 into 2 into 3, which becomes 2 square multiplied by 3. So how I can prime factorize 12 is 2 square into 3 power 1. Okay, so representing any number as the product of prime numbers. So these are two examples, 588. So one way of prime factorizing is, I'm sure you must have done this in your schooling days. So do the normal division. Always start with 2. If it's an even number, continue to, till you get an odd number. Keep on dividing till by the 2, right? So you get a 294 over here and 2, I'll get 147. Now I'll do 3. 3 I know is divisible, 147. So we'll have to do a bit of trial and error over here. So most of us know that 49 is 7 square. So you got to prime factorize till you get to 1. Now how can we write 588 as 2 is multiplied 2 times? So 2 squared, then 3 once and 7 twice. So that's what we got here. Same way, you can try solving for 252. You should be getting 2 square multiplied by 3 square multiplied by 7. Okay, so this is about prime factorization. Any number can be prime factorized this way. Now questions like this can be asked, how many number of positive factors, okay, number of factors are there for any number. For example, if I list down for 12, how many factors are there? So 1 we know is factor of every number. Okay, now what is a factor? You divide a number by a factor, you get an integer, basically something which is completely divisible, right? For example, 12 upon 2 is 6. So 2 is one of the factors of 12. So if we keep on listing 2, 3, next is 4 is divisible, 5 is not, 6 is divisible, then 7, 8, 9, 10, nothing, then directly 12. So if a question is asked, how many number of factors are there? So for 12, we'll say there are 6 number of positive factors. Now, why the word positive? We'll discuss this in great detail in the later parts. So one way is you directly write down, right? List down all the factors. Start with 1 and end with the number generally. That's a good sequence or order to follow. Now, if they ask you to find, let's say, number of factors or positive factors of this number, so it will take a lot of time in the exam conditions, okay, to solve by listing down. So we need a formula, obviously. Now what is the formula? The first step is you will prime factorize. For example, so we take 588, what we have done in the previous slide. So this is something like this, right? The idea is you will prime factorize the number as the bases have to be prime numbers. Remember, the base has to be prime number for sure. So the formula directly follows. The total number of positive factors are going to be irrespective of whatever is the base. It can be 2 or it can be 3, it can be 7, it can be 11, 13, anything, right? The base does not matter. What matters is the base has to be a prime number. Then you will add 1. You will add 1 to the powers or the exponents, right? 3 power 1, you will add plus 1. 2 plus 1. So the number of positive factors are going to be 2 plus 1 multiplied by 1 plus 1 multiplied by 2 plus 1, which is 3 multiplied by 2 multiplied by 3, which is 18 positive factors. Okay, the formula is straightforward. Step 1 is prime factorize to so that the bases are prime numbers. Then step 2 is you add 1 to every exponent and multiply, right? You'll get total number of positive factors. So if you, we can just verify with this also. We got 6 positive factors. If you want to find number of positive factors of 12, so this exponent is 2, you add 1. And the next exponent is 1, you add 1 to that. So what we get? 6. Now the factors can be negatives also, right? That means we have seen that 2 is a factor of 12, right? Because we got an integer, it's completely divisible. Now negative 2 will also give us an integer, right? So that means as many positive factors we have, that many negative factors will also be there. So for example, if 1, 2, 3, all of these are factors of 12, negative 1, negative 2, negative 3. So the number of positive factors and the number of negative factors are same. Okay. So if they ask just to find total number of factors, total number of factors. So you find positive factors and multiply by 2. Okay. We'll solve few questions. Before that, we'll just revise prime factorize. The division method, you divide by 2, 3 and so on and so forth by the prime numbers. Write it in the form of 2 power a, 3 power b and so on. Then if you want to find number of positive factors, after prime factorizing, you add 1, right, to each and every exponent and multiply. Number of negative factors and positive factors are same. So if they ask instead of positive factors, total factors, so you just multiply number of positive factors by 2. So you all can pause the video and try solving this. 144, right? So even number will always begin with 2, 72, 36, 18, 9, 3 and 3. So 144 is 2 multiplied by 4 times and 3 multiplied twice. So 2 power 4 multiplied by 3 square. So if you want to find number of positive factors, straightforward, 4 plus 1 multiplied by 2 plus 1, which is 5 times 3, 15. So we have solved this already. So you can pause the video and try this. You should be getting 2 square multiplied by 3 square multiplied by 7. The third one, 1323. Again, you can, every question, if you feel like pausing the video and solving, do so. Now, this is a big number, so let us try. So 2 is not going to happen, odd number, so I'll try with 3. 3 4s are 12, 1 gets carried, so I get 12. So 4 4s 12 and 3 is there, 1. Yeah. So I'll try for 3. 441, 1 is there, 3. So 1 carries 14. So I have 4, 12. So 2 carries 21, 7. Yeah. So I know 147 is divisible by 3. So it gives us 49, then 7 and 7. So what do we get? 3 cube multiplied by 7 square. Okay. So again, if you want to find number of positive factors, yeah, 3 plus 1 multiplied by 2 plus 1. Okay, an interesting fact, let's say if some number n, instead of, okay, I'm writing a similar number, let's say 2 cube multiplied by pi square. For this sort of number, will the number of positive factors be same as that of 1323? The answer is absolutely yes. Why? The base does not matter. The base just has to be prime. It's the exponents or the powers that matter, right? Next question. List all prime factors. Okay, they're not asking the number of prime factors. They're asking just list the different prime factors. For example, if 12 is there, so the prime factors are just 2 and 3. So step 1 again involves prime factorizing. Even number 297, so this is divisible by 3. 300 minus 3, so I get 99. We'll continue with 3, 33, 11 and 1. So the prime factors, what are the prime factors? Are 2, 3 and, so I'm just writing the different prime factors. Okay, so we can just make that clear. List all different prime factors. Okay, you can try this. So if you try, you get 2 power 9. 5 and 2 is 2 power 9. So I just have one prime factor. Okay. Same way, you can try this question. You should get 2 multiplied by 3 multiplied by 13 square. So the prime factors are 2, 3 and 13. Okay, total factors. So in exam, you have to be extremely careful of positive, negative, total, whatever. So first step is you will find the prime factorization and positive factors, right? So 162, one more 2, 81. 81 we know is 9 square. 27, get 9, 3 and 1. So 324 is 2 multiplied twice and 3 multiplied 4 times. So number of positive factors are, we add 1 to both the exponents. 5 into 3, right? Yeah, 15. So the number of total factors are twice of 15 because we have to include the negatives. Straightforward questions. Okay, one last question. If x is 3 power 28 minus 3 power 25, then what is the longest prime factor? greatest prime factor. Some error in this. So what is the greatest prime factor of x? Okay. So 3 power 28 minus 3 power 25. So what can be taken common here? 3 power 25. Because 3 power 28 is 3 multiplied 28 times, right? So I can write it something like this. We'll see this in the exponents part of it. 3 power 28, 3 power 25 into 3 cube. So what remains is 3 cube minus 1. Now what is 3 cube? Is 27. So 3 power 25 into 26. 26, if I further prime factorize, is 2 into 13. So 2 multiplied by 2, 3 power 25 multiplied by 13. So the greatest prime factor, so there are 3 prime factors, 2, 3 and 13. The greatest prime factor is 13, which is option E. Okay, so I hope this is clear. This is about prime factorization and finding out number of positive factors and total factors. Thank you so much. I'll see you in the next video.